Hello, everyone. Thank you so much for coming to listen to our talk tonight. And especially thank you to the organizers and the room moderator for allowing us to speak at this conference. So we are a group of students from the University of Pittsburgh, and tonight we are here to talk about incorporating solar energy into the oil and gas industry. As a quick note, if you scan the QR code at the bottom of this slide, you'll be taken to a folder that has a complete copy of this presentation and a copy of all the references that we've been using throughout this project. So I'll just go over our agenda for tonight. First, we'll talk about our client and the question we were posed to answer for them. And then we'll go into all the things we've been using to work on this project, including decline curve analysis, oil and gas well locations, solar irradiance data, the importance of location choice, and the overlap between the solar energy and oil and gas industries. And then finally, we'll wrap up with our next steps. So the question we were posed with was, how can solar energy be incorporated into the oil and gas industry? More specifically, is it feasible? Is it profitable? And when would be the best time to switch over to solar energy? So now I'll hand it off to Zach to discuss our client.
Thank you, Megan. So our client is CX Energy, who is a real estate broker based out of Pittsburgh, PA, and they specialize in oil and gas sales in the tri-state area, so Pennsylvania, West Virginia, and Ohio. And what they do is they lease oil and gas rights while also trying to consider responsible land use, environmental protections, and production clauses. So we will be they are considering switching from oil and gas to solar power. So what we can do to help them do this is use a decline curve analysis to determine when it would be most profitable to make this switch. So let's talk about what decline curve analysis is. So it's a forecasting technique for oil and gas production data. And using this technique, we can use data to forecast future production of oil and gas wells, determine when a well will reach its economic limit, which is pretty much when it's no longer profitable for whatever company, in our case, CX Energy. And it can also be useful for determining reserves and the estimated ultimate recovery of the well. And that estimated ultimate recovery, the EUR, is just going to be pretty much the total reserves or the total production of oil or gas that each well will produce. So obviously you can see at the bottom here on this graph that it's a rate over time graph, and the blue dots are going to be rates of production at a specific time, and then the red line following is going to be our forecasted data. So we're going to sort of try and fit that red line to match the blue dots and forecast as well as we can. So obviously oil and gas has been profitable for CX Energy, but our goal is to show that solar energy leasing can also provide significant profitability as well. And doing decline curve analyses, we can help them show which wells are producing satisfactory amounts as well as which ones are not. This can in turn help us decide where to better put solar farms and sort of introduce that new form of energy. So let's talk about how it works as well. So there are three types of decline curves. There are exponential, hyperbolic, and harmonic. But we're only going to focus on hyperbolic and exponential just because we don't see harmonic too much in industry. So we can sort of ignore that for now. So our main modeling equations are going to be represented by Q of T. And this, like I said, gives us a line of best fit for our data. And essentially it just uses the sum of least squares with all of our oil and gas data. And this method will pretty much give us that red forecasted line. And then we can also integrate to find our reserves at the end there in that diagonally redlined box. And then with that, we can use all of our production data that we have, which are those blue dots, and we're going to add those reserves that we integrated to find. And that will give us our total reserves, which is, like I said, is just the total amount of oil that we recovered or oil that is recoverable as well. So obviously there are a bunch of variables here, and it looks kind of daunting to be working with these variables, but I promise it's not. They're pretty simple. They're all just rates and obviously time variables. So like Megan mentioned earlier, you can scan that QR code and it'll show you what all of those variables mean. But other than that, that's pretty much that about decline curve analysis.
And so CX is a company that deals with land and drilling rights. We want to find potential locations for solar farms, as well as their current business of gas and oil wells. This image is a map of large-scale solar projects in Pennsylvania that are either operating, under development, or under construction that was taken from the Solar Energy Industries Association. It can be helpful to look at these locations and determining where good potential areas would be for CX to lease out. Our goal is to find locations that have an overlap of solar hotspots and highly productive drilling locations. Here we have taken Pennsylvania oil and gas well productivity data that is organized by the well's permit number. Using R, this data was cleaned and sorted in order to map out the most productive wells in an overall average production per day ratio. The left graph shows oil wells, where the dark red shows all of the wells, and the brighter red highlights the top 500 wells. On the right, the graph shows gas wells, where the light blue is all wells, and the brighter blue shows the top 500 gas wells. Based on work done by Pitt's CX Energy Group from last year, we can narrow down to the most profitable counties for oil and gas production. We can use these counties as a starting point to compare to solar ratings data. And thus we see solar farms, and thus we can see where solar farms could best be placed. Due to PA's topography and the amount of rain we get, we are very susceptible to landslides. So we must consider this in the most profitable locations. The map on the right is from Pennsylvania Emergency Management Agency, and it shows the areas that are most susceptible to landslides. The counties outlined by last year's CX group in northeastern PA fall in the low incidence and moderate susceptibility category. So although landslides are possible, they aren't very probable in those areas. So now Dan is going to talk about solar ratings data.
So CX Energy has their own data on how much gas and oil their wells produce, but we wanted to do an analysis of the potential for solar viability as well. So what you're seeing is some analyzed data that we got from NASA. So we have elevation in 1 degree latitude by 1 degree longitude sections, and approximately 84 million data points in each of those sections, which we ran a solar model over, which essentially gives us the map that you see on the screen, which is a model of the amount of solar irradiance or sunlight that each pixel gets over the course of a normal year. And so you can see from blue to red, it shows the least to highest solar irradiance. And then we're going to use this data to try and identify the areas that would be most profitable for solar farms to be built on. So taking that digital elevation model on the far left, you can see that we turned it into the irradiance model in the middle, just by running some models through the Environmental Systems Research Institute, and then aggregated that data over the 15 nearest pixels in every direction to get the map on the far right, which reduces it from that kind of broader color spectrum down to one variable that we can more easily measure and recommend to CX areas that have better solar productive capabilities. So you see that the light areas are where solar irradiance is on average higher, and the darker areas are where it is lower on average.
Here, using data CX Energy provided to last year's group, we have calculated the revenue produced each month by every well in terms of dollars per kilowatt hour. We converted the gas quantity of MCF to kilowatt per hour and then found the revenue by multiplying the kilowatt hour by 0.1438, which was the average cost of electricity in Pennsylvania in the fall of 2021. This helps us to better compare the revenues made from oil and gas or from solar energy. On the right-hand side, we have calculated the yearly revenue for just one well, as well as the monthly revenue, just to get a sense of how much money is produced from a single oil well. In terms of a cost-benefit analysis for solar panels, on average, PA farmers pay off their solar farm loan within 10 years from money made selling solar energy. By placing solar panels on the areas with the declining wells or in land which can be used for both drilling and solar, CX Energy will be able to make money from royalties selling electricity. The average return of investment for these farmers is 12.79%. By using solar energy and oil drilling, CX Energy will benefit in the long run in terms of not only a more clean energy initiative, but profits as well. Solar panels and oil and gas wells have a similar lifespan of 20 to 30 years. Though oil and gas wells produce more electrical output, we have not taken into account the cost of maintenance and plugging oil wells when their lifespan is done. When studying this, we may find that solar panel maintenance comes at a lower cost than oil and gas maintenance. Based on our past work, we can conclude that solar power may be a viable option for CX Energy to pursue in strategic areas of Southwest and Northeastern PA. In the future, we hope to further optimize solar and well locations, and we will create a solar viability dashboard for CX Energy and a landslide susceptibility model. We hope to help CX Energy shift to a cleaner energy initiative. Thank you for listening to our talk. We are ready and willing to answer any questions you may have.